All right, this is module 1, lesson 2. We're going to be talking about ratios of fractions and their unit rates. So we're still going to be working on unit rates just like yesterday, but we're going to add some fractions into those unit rates. So first example says, during their last workout, Izzy ran 2 1/4 miles in 15 minutes. Her friend Julia ran 3 3/4 miles in 25 minutes. Each girl thought she was the faster runner. So based on their last run, which girl is correct? Okay, it says use any approach to finding the answer to this. So first thing we're going to do, there's actually 2 ways to do this. The first way we're going to do is create a table for each. So let's look at Izzy first. Let's create a table with minutes being compared to miles. All right, if you look up here, it says that she runs 15 minutes and she goes 2 1/4 miles. Now we can add some more to this table. Let me move this up so you can see it. Okay, so we're going to add another 15 minutes. So we're going to add another 2 1/4. Now, if you need to, we can use the calculator on this. This is a new calculator this year, so I'm going to explain this, how to use this. This right here, the button right below the second button, is our mixed number symbol. So we're going to hit 2 for the whole number. And when you do that, it automatically types in a fraction. You're going to type 1 on the top, use the arrow buttons to move it down. And then you have to use the arrow buttons to move it over. So 2 1/4. We're going to add a 2 1/4 again and hit enter. Now, this shows that it's 4 2/4, but that arrow says it can be simplified. If you want the simplified version, you hit this simplified button and hit enter. Okay, so that would be 4 1/2. Let's add another 15 minutes, which means we're adding another 2 1/4. So I'm just going to add 2 1/4, which would be 6 3/4. Let's add another 15 minutes. So let's add, I didn't want that. So 6 3/4. And we're going to add 2 1/4, which would give me 9. And the last 15 minutes, if I add 2 1/4 to that, you get 11 1/4. All right, we're going to stop there. Let's go and make a chart now for Julia. Let's compare minutes to miles. So for Julia, it says that it takes her 25 minutes to run 3 3/4 miles. So that's our first values in our chart. Now we're going to go increase by 25 minutes, which would be 50. Now it's 3 3/4. And we're going to add another 3 3/4. This does reduce. I want the simplified answer, which is 7 1/2. Okay, let's add another 25 minutes, which means we're adding another 3 3/4, which is 11 1/4. Okay, I'm going to stop there, and you'll see why we're stopping there in a second. Now, notice at 75 minutes, Izzy has run 11 1/4 mile. Julia, at 75 minutes, has run 11 1/4 mile. So same amount of time. They went the same amount of distance. So which girl is correct? Well, they're both wrong because they both ran at the same rate. So neither is correct. Because they ran at the same rate. Okay, so how can we use these tables to produce to determine the unit rates? Well, if we want to find a unit rate, we are simply going to divide. Now, instead of creating the table, we could have done this right from the beginning to see who has the faster unit rate, but we're going to do that now. Now, we are going to be finding the miles per minute. So I'm going to draw my box showing that the miles is going to be on top, minutes is going to be on the bottom. And we're going to look at Izzy first. Now, back in the problem, it said that Izzy ran 2.25 miles, and it took her 15 minutes. All right, I'm going to show you how to divide this by hand just because on the homework it does require you to do it by hand. So I'm going to show you that you have to write this when you have fractions horizontally. Now, you can't divide with mixed numbers, so we have to change this to an improper fraction. So 4 times 2 is 8, plus 1 is 9. Now, when you're dividing, remember you have to do leave, change, flip. So I'm going to do that next. And then I'm going to cross cancel. I know 3 goes into 9 3 times, 3 goes into 15 5 times. So 3 times 1 is 3, 4 times 5 is 20. Okay, so that's for Izzy. Now we're going to do the same thing for Julia. So this information was 3 3/4 miles divided by 25 minutes. So let's do it straight across. 4 times 3 is 12, plus 3 is 15. Let's do leave, change, flip. Now I can cross cancel here. 5 goes into both of those, and I get 3 out of 20. And notice that they are the same once I find the unit rate, which tells us that the rates are their speeds were the same. The rates were the same. All right, so let's go to the next page. Example 2 talks about a turtle that walks 7/8 of a mile in 50 minutes. What is the unit rate when the turtle's speed is expressed in miles per hour? That right away tells us we're finding the unit rate. Per means to divide. So to find the turtle's unit rate, Meredith wrote the following complex fraction. Explain where 5/6 comes from. Now, before we do this, remember when I told you that unit rates are best found by setting up a label? Well, if it's miles per hour, then our label would be miles divided by hours. Now, it says that she walked 7/8 of a mile, so that's why that's on top. But then it tells us she walked 50 minutes. But look at the bottom of units. This is hours. I don't want minutes. So how did they get 5/6? Well, 50 minutes compared to an hour, you would put 50 over 60. There are 60 minutes in an hour, and that reduces to 5/6, which is where that comes from. So that's because they were different units. Now, part B says, let's actually determine the turtle speed. So I'm going to take that problem from up above, and I'm going to write it horizontally. I'm going to do leave, change, change. I know that 2 goes into 6 3 times, 2 goes into 8 4 times, and I'm going to multiply. So that's 21 over 20, which would be miles per hour. All right, so let's go to exercise 1. This one says for Anthony's birthday, his mother is making cupcakes for 12 friends at his daycare. The recipe calls for 3 1/3 cups of flour. This recipe makes 2.5 dozen cupcakes. Anthony's mother has only 1 cup of flour left. Is there enough flour for each of his friends to get a cupcake? Okay, well, right here we can see that we're looking for a unit rate with 1 cup of flour. Now, 1 is always the bottom unit, so that would be our cups of flour. So the other units that we're talking about are dozen cupcakes. So it's asking us to find the unit rate to see how many cupcakes 1 cup of flour would make. So here's our information. We have 3 1/3 cups of flour, 2.5 dozen cupcakes. So cupcakes goes on top. Flour goes on the bottom. All right, now I can't do that vertically, so we're going to do it horizontally. I'm going to rewrite it. Change it to improper fractions. So this would be 5 over 2. And that would be 10 over 3. I'm going to do leave, change, flip. I'm going to cross cancel before I do this, which leaves us with 3/4. Now that's talking about 3/4 dozen cupcakes per flour. And then I got that right from this label that I made before. Now, if this 1 cup of flour only makes 3/4 of a dozen, but he has 12 friends, we need 12 cupcakes. Will he have enough? She will not have enough. She will only be making 9 cupcakes. So she will not make enough. All right, next page. We are going to go through the last example, number 2. Sally is making a painting for which she is mixing red and blue paint. The table shows the different mixtures. So it says, what is the unit rate for the amount of blue to the amount of red? So our label is going to be blue to red. This is our label. And we're going to find the unit rate. We can actually use any of these numbers, pairs of numbers. It doesn't matter to me which one we use. So just pick one. Let's say we pick this nice one right here. So blue paint goes on top. Red paint goes on the bottom. I'm going to grab my calculator for this. So 2 divided by 1.2 gives us 1.666666. Okay, that's 1.6 repeating. Remember, the 7 is only there because the calculator rounds it. And that would be our unit rate for blue to red. So what does that mean in words in the context of this problem? So if you look at your label, that will help you determine what this means. So it's talking about the quarts of blue paint compared to the quarts of red paint. So what this means is you would use 1.6 quarts of blue paint for every 1 quart of red. Because remember, it's a simplified fraction, so the red is on the bottom, so that would be 1 quart of red. All right, on the next page is your problem set. You're going to try that out for homework, and we will go over that in class tomorrow. Good luck.